In this question, we will be discussing the absolute core pieces of Matplotlib. The figure and axes are the entry point that you want for every single one of your drawing methods. They are the most powerful way to control your visualizations and my absolute favorite way to interact with graphs. When you start thinking in terms of figures and axes, you'll quickly realize that Matplotlib, everything is what they call an artist. An artist is simply something that knows how to draw itself. And it's differentiated into two different types of artists. There are container artists and there are primitive artists. Container artists are, example, the figure and axes objects. Container artists are simply artists that contain other artists. And you'll see here that we have this odd nesting, right? The figure is a container, and then the axis is a container. And what does the axis contain but more containers? And then at some point, right, it can't be turtles all the way down. At some point, we have to reach what we call the primitive artists. These are the things that know the specifics about how to draw themselves. These are your things like lines, like rectangles, like circles. They're what draw your line plots, your bar plots, your scatter plots, for example. And so when we think of the figure and axes, these are just the parents, right, that just at some point contain something that we can draw. And so like I've said, our figure is kind of our sheet of paper here, and our axes are a visual set or a representation of a set of an x and y axis. And if we look at where the figure inherits from, we can trace this back and see that the figure is indeed classified as an artist, and the axis is also indeed classified as an artist as its first level after the basic Pi object. That's great, right? We know that these are containers, but what do they contain? Well, let's take a look using the getChildren method at what a figure actually has inside of it. We can see here that there's a matplotlib.patches.rectangle and then also an axes.subplot. Little bit of thinking tells me that the axes subplot is the actual axis that I made using the subplot entry point, so we can kind of ignore that for now. But what's interesting is that I just made an empty figure with an axis, and there's a rectangle on it. What on earth is that rectangle? Well, that rectangle turns out to be the background of our plot. Matplotlib does this as a convenient way for us to be able to control the background of our figure. And our figure just has this empty rectangle on it that comes by default white when you're using standard Matplotlib style. And we can use this actual primitive artist to change the face color. We can change its alpha value. There are certain parameters, certain shared attributes that these primitives have that we can tweak to let us change absolutely every single part of our plot. And knowing which primitives are attached to which of these containers is very powerful in letting us make some of these fine-tuned adjustments. In fact, these default values are actually stored as different attributes of the figure container. You can see that we can tap into fig.patch and fig.axes to get that rectangle, that background, and all of the axes that are attached to a given figure. And now I've talked a lot about attaching, right? We're adding these artists to the container artists. And this is why Matplotlib has these entry points of things like ax.plot, ax.bar, because Matplotlib has to know which axes we're adding these rectangles, we're adding these lines into. And that's why we always tend to use this interface instead of doing some fig.patch, right, equals rectangle. We tend to not do that because there is a lot of plumbing, like I've mentioned, that needs to happen when we actually add this rectangle. And Matplotlib actually predates property accessors, so your your property.setAttr and your property.getAttr, and that's why we see all of these set_attribute methods or these get_attribute_name methods, because that lets us follow the logic of Matplotlib's plumbing, but while also being able to update and dynamically change its attributes and just letting Matplotlib know that we've changed its attributes. And so if we look at the axes, here, we can see that it contains a very similar layout of children, plus just a little bit more. We see that there are 4 spine objects. We see that there is an x-axis object and a y-axis objects, 3 text objects, and then 1 rectangle. Now, focusing from the end of the list going backwards, the rectangle, by logic, we can kind of assume that that's the background of the plot itself, just like the figure, right? Nothing too surprising there. Before that, we have the 3 text objects. Those correspond to the title and X and Y label, which we haven't yet set. And then we have the y-axis. Also, text isn't a primitive artist, so I do want to clarify that. We have the y-axis and x-axis, which are actually themselves containers, right? This is the whole point of having an axis, because it controls your set of your x and y-axis, which, if you're doing any data visualization, kind of need an x and y. And then we have the 4 spine objects. What are those spine objects, though? You can see that they're stored here in the ax.spines attribute, but when I access ax.spines, I get a spines plural object. Oh my goodness. Matplotlib has containers on containers. The nesting does go quite deep. And in order to understand it, you have to just follow the nesting. And if you examine the spines object, you can see it's actually a dictionary that control each of the spines of a given figure. And what the spines are, they're simply the lines that draw the default border, right, around your plot. So your left spine is obviously, it's the line drawn on your y-axis there. And just like any spine is actually a primitive artist, so I can set things like its color, I can set its line width, I can set even its bounds, right? Where does it go? And I can do the same for the bottom spine. I can change attributes of the right and of the top. I can have all these different attributes that I can play with, that I have at my disposal, to create a plot that literally does everything I want it to, that looks exactly the way I want it to. And so when you're thinking about communicating results, you always want to have a very clean looking plot. If I were to submit a plot for publication as part of, say, a scientific article I might be writing, I'm not going to be sending in just some df.plot, call it a day, right? I'm actually going to be taking the time to make it aesthetically pleasing in order to communicate the message that I want it to communicate. And so having these fine level details hammered out is very important. Next, a part of the axis object, we have the X and Y axis. And these, as I mentioned earlier, are containers themselves. So in order to do something meaningful with them, we have to do just a little bit of inspection. And to differentiate the axis from the spine, I'll show you what the axis is without the spine being shown. The axis is very simple. It's the ticks and it's the labels. The ticks are those very tiny little hash marks that you see just above my 0.2, 0.4, 0.6, and 0.8. And if that's hard to see, we can make that bigger, I'll show you. But knowing how to set each of these ticks, set each of these labels, is a very powerful thing. We can actually use some fairly convenient methods, right? A lot of the parent containers in Matplotlib have methods that will set properties on its children for you. And this is mainly just to avoid you some type of explicit loop. I don't have to say ax.xaxis labels or something like that, or tick labels if I want to change the labels of the ticks and then set all of them individually. And so we can use this kind of convenience, parent reaching into the child artist to set some very convenient things. I can even set the position to the top, and I can move it so it doesn't appear in the middle, but maybe my X label appears off to the left. And so I wouldn't say it's important to know all of these methods explicitly, right? These are things that you can look up in the documentation. What's important to know here is that your figure is a container, contains one or more axes, more often than not. Your axis is a container. It contains spines. It contains your X and Y axis. Your X and Y axis, again, a third level of container. And underneath that, you'll find the things that are actually drawn to the screen. And so if I wanted to set my X label in a very kind of manual way without using these convenient methods attached to the axis object, I can simply just say, Stop messing around with me, Matplotlib. Just give me the label. I'll do this myself. Right, and I'm actually able to just fine-tune the text primitive artist in any way that I want, and that's reflected and drawn to screen. Now you do have to take some level of care with this because, like I said, these convenient methods, these setters and getters are there sometimes for a reason. And so just note that when you are grabbing some primitive artist out of a container and manually setting things on it, that there could be some transformation steps that you're missing that's controlled by the convenience methods of the parent container. Next, my favorite part actually about the X and Y axis. You can set the ticks and the labels in any way that you want. So if I wanted, instead of going from 0 to 0.1 by steps of 0.2, I wanted to say Matplotlib or axes, give me ticks every 0.25. I can use some NumPy to do this. I can say, okay, give me the minimum and the maximum of my X limits. Now give me an A range with a step of 0.25 from NumPy. Okay, I know that doesn't include the endpoint, so I'm going to need to add that back in. So give me that maximum X limit again, and those will be my ticks. Now you can see that you can run into some issues here because A range excludes the endpoint by default, but when you use a floating point value as a step, just because of the way that floating point numbers are added, right, you could have just a little bit of rounding error, and so you could actually end up including that endpoint just by mistake, just because of the interaction between A range and using a floating point value. So maybe you say, I'll use something like linspace, but then we don't get values every 0.25 steps. We have to do a little bit of math to figure out how linspace will return these axes or will return these ticks and where they'll be. If you ever do that, I encourage you to stop. Use the axes locators that Matplotlib has given to us. Like I said, a lot of conveniences. And what you can actually do is just say, Matplotlib, when you draw this plot, right, just give me the X ticks every multiple of 0.25. I can use this multiple locator. I don't need to mess around with the current X and Y limits of the plot. And in fact, this is even better because if I were to change the X and Y limits of the plot after I set this, we'll still get the correct ticks that we're expecting. We can also use something like a linear locator to say, I don't care how you do it, Matplotlib, just give me 4 points along that x-axis. And this is kind of the same distinction that we made before with A range and linspace in NumPy. And there's also this notion of minor ticks. And what those are these very small hash marks between what we call our major ticks, or ticks that have labels, let's be honest. And we can actually play around with these ticks just to make it a little bit more obvious what I'm talking about here. The minor ticks are the orange points, and the major ticks are the black points, the very black, big hash marks. And we can also use an auto minor locator to say, Matplotlib, I don't care how you do it, give me n-1 hash marks between each set of major ticks. And so you have these great methods for tweaking the plot in any way that you want, and I strongly urge you to use these locators and to use these formatters. What Matplotlib gives you is the ability to change the labels associated with our ticks based on some string, based on some function, or even we can use a null formatter to simply remove them all. Yes, we can tap into this stuff using ax.xaxis.setTickLabels, but what this doesn't do is this doesn't perform any operations based on the ticks themselves or the existing labels. You'll have to set up a getXTick or getTickLabels, operate on those to transform them if it's categorical. This can be problematic because, well, I haven't yet inspected what the ticks themselves are, so I need to do something based on the tick values, right? The position, the 0.2, 0.4, 0.6, 0.8. And so when you're using the set XTickLabels or set tick labels on the x-axis, you should always use it in correspondence with set xticks or set ticks on the x-axis. But we can use this formatter to, maybe format, add a $sign in front of each label and take the value out to 4 decimal places. When we use a formatter, it's good to know that Matplotlib passes in x, an argument x, to the string.format method, x, which is the current label, and a POS, which stands for position. And you can use a function, right? Matplotlib has the ability to support functions, so as it just has to take x in position, and you can transform the label in any way that you want it. Here I have mapped it to some actual characters instead of numbers based on their value plus 64. And so this type of explicit control over your plot and thinking of your figure as a container that contains the axes, and the axes as a container that contain your y and x axis, and your y and x axis as a container that contains finally the actual things we'll be drawing on the axes, on the x and y axis themselves, we start to realize that Matplotlib has this tree-like structure where it's not just a straight top to bottom tree, because the axis is aware that its parent is a figure. The x and y axis are aware that its parent is this given axis. And even your axes will be aware who the figure is 2 steps up, who the parent is. And so we have this tree-like structure that behaves somewhat in like a graph, such that Matplotlib knows how everything is related to each other and knows how to draw it all when we ask it to draw.